This is just an ordinary bolt. And everyone watching right now is absolutely sure they know how to use it. However, to use it correctly, you need to consider several important details. There are specific rules for the order in which to place the washer and the nut. I'll explain these rules and also talk about the different types of nuts and washers. So today, you're watching the most useful video on my channel. For clarity, I made this demonstration model. It simulates two parts for a through connection and for a blind connection. This model represents two parts, and here a part is attached to a body. Let's start with the basics. The simplest and most classic connection is a bolt, a washer, and a nut. By the way, whenever I show fastening elements, I'll also provide their DIN, ISO, and ASA standard numbers, just in case. This is the second option, when a part is attached to the body of the product. Here, only the bolt and the washer are used. The connection will also work without washers. But then the question arises, why do we even need washers? The main function of a simple flat washer is to protect the surface of the part. The washer distributes the load evenly and prevents the nut from damaging the surface. This is especially important for painted or galvanized parts. There are certain rules that must be followed. This is the correct way. The washer is placed between the rotating element, the nut, and the stationary part. This is also correct because the bolt rotates and the washer protects the surface. But this is wrong. The bolt does not rotate, and the washer's area is the same as the bolt head's area. In this case, the upper washer is completely pointless. It's not needed for protection. And this option is also incorrect. However, an impatient viewer might argue that a washer under the bolt could protect a soft material from being crushed. A standard washer won't do that, but this kind of washer will. This is a wide washer for soft materials. It distributes the pressure more evenly and reduces the risk of the material being crushed. They can also be used with thin sheet metal to minimize the risk of deformation. Everything here is the same as with a regular washer, except that you can use two washers at once to avoid crushing something like plywood. And the mistake in the last example is not that there's a washer under the bolt, but that there's nothing under the nut. And here's an iron rule: if an element rotates, there must always be a washer between it and the part. Now for the most interesting part: different solutions to prevent bolted connections from loosening. The most popular option is the Grover washer, although its real name is a spring split washer. This washer works by flexing and creating elastic tension. The raised sharp ends only slightly add some extra friction. If the connection doesn't use a nut, the spring washer can be placed either between the regular washer and the bolt, or between the bolt and the part. In the right-hand example, the effectiveness of the washer drops sharply. The left-hand option is the correct one. The center option is also acceptable, but you have to keep in mind that the washer will likely damage the surface of the part. And the right-hand option is completely wrong, because when tightening the nut, the washer can deform and open up. That's why it's standard practice to place the spring washer on the bolt side, not on the nut side. However, today there are much more effective solutions for preventing loosening. The next development after the spring washer was the external tooth lock washer. It prevents the nut or bolt from loosening by biting its teeth into the contact surface. Its main use is on vibration-loaded surfaces and in electrical connections. External tooth washers are used without flat washers and should be installed under the rotating element. In this case, under the bolt. And here, the nut rotates, so the washer is placed under the nut. This is because this type of washer works not by the material spring tension, but mainly by increasing friction, although the friction is still caused by some elastic pressure. These washers are used in threaded connections operating under dynamic loads, and thanks to their elasticity, they maintain constant tension in the assembly, preventing it from loosening. A conical, Belleville, washer is excellent for connections that are exposed to temperature changes. It constantly keeps the connection under tension. These particular washers have increased thickness and are designed for higher loads. It's hard to make a mistake here, and the main rule is, the washer must be installed with the wide side facing the part. For the connection to work as an elastic system, it doesn't matter whether the washer is placed under the nut, under the bolt head, or under both. Installing washers on both sides doubles the system's elasticity. A logical evolution of the simple conical washer is the ribbed conical washer. This is a unique product offered by only a few brands, including Worth. It combines the advantages of both a conical washer and a toothed washer, but it also has several unique features. It is reusable and has a reduced outer diameter. The ribbed conical washer must be used only under the rotating element. If the part is made of soft material, it's acceptable to place a flat washer underneath. Also, the washer must be installed with the wide side facing the part, not the bolt. However, the most correct method is to install it under the nut. Installing it under the bolt will hardly improve resistance to loosening. You must not install two ribbed washers at once. And when installing, it's important to make sure the wide side faces the part. The main function of the ribbed conical washer is to prevent self-loosening, not to regulate preload like a simple conical washer, so using two ribbed washers only reduces the stiffness of the connection. And finally, the pinnacle of washer development, self-locking washers. They outperform traditional lock washers because they use a wedge effect to prevent loosening under vibrations and dynamic loads. Unlike spring or toothed washers, they do not rely on tightening force and can lock the connection without increasing friction, while maintaining the bolt's preload. These washers have only two limitations: they must not be used together with other washers, and they must always be installed in pairs. It is recommended to place the washer under the rotating element, in this case, between the nut and the part. However, it's also acceptable to install two pairs, one under the bolt and one under the nut. Washers are just one way to make a threaded connection more reliable. There is another great method, self-locking nuts. The simplest way to lock a connection is with a jam nut, meaning you take another identical nut and tighten it after the main nut. A nylon insert inside the nut deforms when the bolt is tightened, creating additional friction that holds the connection even under vibrations. Some people say these nuts are single-use, while others disagree. And both are right. The point is that nylon is very elastic, and even though the bolt thread cuts a groove into it, the nylon still retains its elastic properties even after reuse. However, it is not recommended to reuse them more than 2 or 3 times. Usually, only a flat washer is used to protect the surface of the part. Of course, these nuts must be screwed on from the side without the nylon ring. Although I've read that some very gifted people somehow manage to screw them on the wrong way. When using a nylon insert nut, no locking washers are needed. A flange nut is designed to evenly distribute the load and prevent loosening without the need for additional washers. The main feature of this nut is that it allows you to skip the washer, speeding up the work. These nuts come with either a serrated flange or a smooth flange. The serrated ones provide better locking, while the smooth ones simply protect the surface under the nut from damage. Naturally, they are installed without any washers, with the wide side facing the part. A cap nut has a closed top that protects the end of the bolt from dirt, corrosion, and mechanical damage. It provides a clean, aesthetic appearance and prevents injuries that could be caused by an exposed bolt end. That's why this nut is used anywhere there might be contact with human body parts, for example, railings, fences, bicycle frames, furniture, and other places. This nut has no self-locking properties, so it can and should be used with the same washers as a regular nut. The only limitation of a cap nut is that the bolt must not stick out beyond the cap, otherwise you simply won't be able to install it. A prevailing torque nut prevents loosening through preloaded, deformed threads that create increased friction between the nut and the bolt. Unlike a nylon insert nut, this is a fully metal construction. It can withstand high temperatures and aggressive environments. Lubricants must not be used with this nut, because they weaken the locking effect. Show oil being poured onto a joint in reverse. A washer is only needed if you want to protect the surface from mechanical damage, and of course, these nuts are used without any locking washers. I also have an old nut of this type. It's also M10 with the same thread pitch, but it's clearly not a high-strength version, more like a low-strength one, and it weighs about 4 times less because it was used in aviation. There are also some more radical ways to lock a nut, and these two methods provide a 100% guarantee against loosening. A weld nut is designed for rigidly securing a threaded connection by welding. It's used in structures where the nut must be permanently fixed, without the possibility of turning or falling out. These nuts are made from high-strength carbon steel and are not galvanized. The most correct installation method is welding at 3 points where the nut has its legs. If you weld around the perimeter, there's a risk of burning through and damaging the threads. And even if you do weld the whole nut, it's recommended to do it with spot welds to avoid overheating. Castle nuts are used together with a cotter pin to prevent loosening. These nuts have slots on the top, shaped like a crown, through which the cotter pin passes, locking the nut in place. This type of connection provides maximum protection against loosening, which is why it is widely used in aviation. After inserting the cotter pin fully, its legs are bent in opposite directions and tucked into the slots so that they stick out as little as possible. If you need to protect the surface of the part, you can place a flat washer under the castle nut. And if preload is required, you can use a conical, Belleville, washer. Thank you for watching. See you.